Numeric operators in Python are symbols that assign, modify, or compare numeric values. We've been using one operator already, the assignment operator. When we write a equals 3, we say that the number 3 is assigned to the variable name a. Up to this point, I've been careful to say that a refers to the number 3, because in Python what really happens is the number 3 is stored in memory, and then the variable name a is set to refer to that location in memory. If I say b equals 3, Python only stores the number 3 once and then points both of these variable names to the same object in memory. But in general, we won't really worry about this, and we'll be pretty loose with the language and say we're assigning the number 3 to the variable a. Beyond the assignment operator, we have unary operators that act on a single number. So if I say b equals negative a, and then print the values of a and b, of course, a equals 3 and b equals negative 3. The unary operator changes the sign of a number so that if a were originally negative 3, of course b would become positive 3. Most often we use binary operators. Binary operators use the value of two numbers to create a third result. The addition operator plus is a binary operator. It takes the value of the number on the left side of the plus and the value of the number on the right side and adds them together in the usual way. We can see this if we print out a equals 1, b equals 2, and a plus b equals 3. If you haven't done much programming before, you may be surprised to see an expression like this. And I use the word expression because this is not an equation in Python, even though we see the equal sign here. Remember that the single equal sign is the assignment operator. First, Python looks to the right of the equal sign and evaluates this expression, a plus 1. Since a was already equal to 1, a plus 1 will equal 2. Then the assignment operator says, take the result of that expression on the right-hand side and assign it on the left-hand side. So the value of a is updated to 2, the original value of a plus 1. That's a little hard to get used to at first, but you'll get comfortable with it pretty quickly. Incidentally, we can shorten this expression. If we're using a on both sides of the assignment operator, we can just simply say a plus equals 1, which means take the original value of a, add 1 to it, and assign the result back to a. And we see we get the same result. A is now 2. So a equals a plus 1 and a plus equals 1 mean the same thing. The second binary operator is the subtraction operator, and it works just the way you think it would. And in fact, we have a shortcut for subtraction as well. So we would expect a minus b, 1 minus 2, to equal negative 1. And if we subtract 1 from the original value of a, we should get 0. Let's make sure. A is 1, b is 2, a minus b is negative 1. And if we subtract 1 from a, we get 0. We can't use x for multiplication in Python because x is a letter and that would be confusing to the Python interpreter. And there's no easy way to get a dot like we use in math, so we use the star symbol, or asterisk. Let's make these numbers a little more interesting. So a is 3, b is 2. We're going to take a times b, 3 times 2, and place the answer in c. So 3 times 2 should equal 6. Let's run this and then we'll talk about the shortcut operator. So a is 3, b is 2, a times b equals 6, just as expected. Now we can say something like a equals a times 7. And again, Python will evaluate the right-hand side of the assignment operator. 3 times 7 should equal 21, and place the result back into a, which it does. But again, we can use a shortcut operator for this. A times equals 7 takes the value of a, multiplies it by 7, and places the result back in a. Python knows about order of operations, so if we add another operation here, Python should take care of the multiplication first and then the addition, just like in math, but let's be sure. If Python did this wrong, it would get 12. Let's see what happens. A plus A times B equals 9. Fantastic. And if we really wanted 12, we would need to put parentheses around the A's. Again, there's no easy division key on the keyboard, so if we want to divide two numbers, we use the slash. We'll say C equals A slash B. A is 6, B is 2, so we expect the answer to be 6 divided by 2 equals 3. And in fact it is. The answer may be a little surprising though. Notice that A was 6, B was 2. A divided by B is listed as 3.0. Let's explore that a little. We'll print the type of each variable. A's type is integer, B's type is integer, but when we perform division, we find that C's type is float. That's because usually when we divide two integers, we get a fraction. For instance, if A were 5 instead of 6, we would get 2.5. We'll see that our shortcut also works with division. But what if we wanted the result to be an integer? If we want to divide 6 by 2 and we want an integer result, we can use floor division, which is two division signs. The result of floor division is always an integer. If we evaluate 5 divided by 2, Python performs the division. 5 divided by 2 is 2.5, but then rounds the answer down to the nearest whole number. So 2.5 becomes 2. It's worth repeating that we are rounding down. 2.5 would normally become 3, but with floor division it becomes 2. And in fact, if A is negative 5, we might expect negative 5 divided by 2 to give us a result of negative 2 using floor division. But in fact we get negative 3. Python always rounds down in floor division so that negative numbers become more negative. There are two more operators to consider in Python. One is the modulus operator. The modulus operator is represented by the percent sign and gives us the remainder when we divide the first number by the second one. So 17 divided by 4 is 4, but the remainder is 1. The modulus operator gives us the remainder. And the last of the basic arithmetic operators we'll consider is the exponent operator. Supposing we want to raise 3 to the power of 4, you might think we would use the caret, just like we do on the calculator, but that turns out to be a different operation. Instead, we'll use a double asterisk. And 3 to the 4th power is 81. For most of the examples I gave here, I used integers, and usually positive integers. But all of these operators work with floating point and complex numbers as well. And I encourage you to play around with that and see what kind of results you get.